Hi, algebra students. It's Miss Carol, pre-algebra students, sorry. I am back for our project 5. This is our last project of this course, and we will have project questions in lessons 21 through lesson 25. So we're going to start off today with the questions from lesson 21. We've only got 3 questions to answer, and they're pretty easy, so bear with me. We are dealing with the Cartesian coordinate system here, and it's actually pretty fun. Hopefully it's something that you've seen before. The obstacle course is set up as a grid, like a giant coordinate plane. The place where Helena begins is the starting point, or the origin. North is along the positive y-axis, and east is the positive x-axis. Looks like there's a spelling error there. South is the negative y-axis, and west is the negative x-axis. So, first question is, for the first part of the obstacle course, Helen needs to sprint as fast as she can to checkpoint A, which is located 5 units to the north of her starting point. So what I'm going to do here is I brought up a little grid, and remember she's starting here, okay, and then she's going to go 5 units, and we decided that this was north, south, east, and west. Okay, so she's going 5 units to the north. 1, 2, 3, 4, 5. Okay, so she's going to be here, and this is our point. If we were marking these as an ordered pair, this would be an ordered pairs. We always write as x first and then y. Okay, so this would be at the point 0 and 5. Okay, so 5 units to the north. So then let's go back to the answers here. And so as a mapping statement, we're not necessarily acknowledging starting at the origin. We're just acknowledging that we're starting at an x value. Our x value happens to be 0, but we're starting at an x value, okay? That x value is not going to change, but our y value is going to go up by 5. So the only one of the possible answers that meets that is this one, because our x value isn't changing, but our y value is going up by 5. Okay, so let's scroll down to question 2. West of checkpoint A, which is located at 0 and 5, as we just figured out, there are 2 hurdles that Helena needs to jump over. Hurdle 1 is located 4 units to the west of checkpoint A, and hurdle 2 is located 3 units to the west of hurdle 1. So then checkpoint B is located 2 units to the west of hurdle 2. So we've got 4 units to the west, 3 units to the west, and 2 more units to the west. So let's go see back at our coordinate plane. Remember, we were up here at 1, 2, 3, 4, 5. We were up here at 0 and 5. Okay, so that was checkpoint A. Go ahead and write that. Okay. And then checkpoint B was at 4 units. Okay, so hurdle 1 is at 4 units to the west, okay? And hurdle 2 is 3 units after that, okay? So this is hurdle 1, hurdle 2, and then the checkpoint B was 2 more units to the west. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9 units to the west. And what they're looking for are the coordinates. So this is at x equal -9, and y is 5. So that's what we're going to type in right here. Coordinates of checkpoint B are located at -9 and 5. Okay, only one more question remaining. To get to checkpoint C, Helena needs to run north 6 units, crawl through a 4-unit long tube to the east, hopscotch 3 units to the south, and jump 1 unit to the east and run south for 3 units. Oh my goodness. Okay, so let's just kind of add up our easts and wests here. So let's see that north would be +6. Okay, and remember we're at -9 and 5. Okay, so north is +6. And let's just look at north and south to start out with. So +6. This is to the east, so we're going to skip that. Hopscotch south 3 units, so -3. Jump 1 unit to the east. Okay, so we're going to ignore that for a bit. And then run south another 3 units. Okay, so whoop, that is too big. Run south another 3 units. Okay, so 6 -3 -3, 0. We're not going to change our north-south coordinates at all. So that y value is going to remain the same. Okay, now let's check out our east-west. Okay. Okay, we have a 4 unit to the east, and our east is our positive x-axis, so we'll say +4. And 1 more unit to the east, so +1, and that's it. So we're adding 5 to our x-axis, so -9 + 5 is a -4. All right, so our new coordinates would be a -4 and +5. Okay, so those are our coordinates for point C. I'll go ahead and start typing here. So that's answering the first question. C coordinates are -4, 5. What would be an easier way to get from checkpoint B to checkpoint C? Well, since she didn't actually change, since she came back to the same location for our y coordinate, she could easily have, instead of going around and doing all those things, going to the north, then going through the tube, then hopscotching, she could have just walked to the east 5 units. So simply walking to the east would have gotten her to the same C coordinate. And then the last one, how might you be able to figure this out? Just by reading the description of the translations. So I think that what we did was figure it out using the description of the translations. We could have gone to graph paper and drawn it, but I'm going to go ahead and list what we did. So we simply added the north-south movements together and decided that she ended up in the same place vertically. We also added the east-west movements and realized that she moved 4 units to the east. in, let's see, from her negative, or 5 units to the east, sorry, 5 units to the east from her -9 location. Okay. Hopefully that makes sense to everyone. We could have also gone to that graph paper and moved 6 units up, 4 units to the right, 3 units down, 1 unit to the right, and then another 3 units down, okay? But instead, we just figured it out mathematically instead of visually. So thank you so much for joining me, and I will see you back here for our Lesson 22 project. Thank you.